Hi guys, today we're going to be talking about the disk method. So we'll be finding volumes of shapes that look like this. So what does the disk method look like? Let me show you a quick video or animation of what the disk method is. So the disk method is a way to find volume of a specific type of solid. So last time we had a region R and then we had slices or cross sections that would pop up vertically off the base of this region. Well, this time we're going to do it a little bit differently. We'll still have a region R, but this time we're going to take that region R and we're going to revolve it around an axis. We're going to revolve it around either an x-axis, a horizontal line, or something, but we'll revolve this way. And here's another animation of it. Taking that, revolve it around to make a solid. And what you'll notice on these, as soon as I can grab my pen, what you'll notice on these is there's still cross section. So we can still use what we know about finding the volume using cross sections. Because if I were to take this picture and I were to slice it vertically, I would create cross sections. I'm trying to trace what they would look like. Cross sections that would be a circle. I'll try to draw another ellipse here to show you that I end up having a cross section. Whoa, cross section, that's a circle. So the radius becomes this distance. Whatever this curve is, minus that curve. And so we can stick with, to find the volume of the solid, we can stick with the basic formula we were using. The volume is going to be the integral from A to B of the area of the cross section dx. The only difference is with the disk method, the cross sections are all circles with the disk method. And that's why it's called the disk method, because all the cross sections look like circular disks. So I can be a little more specific here and say that the volume is going to be the integral from A to B of pi r squared dx when we integrate with respect to x. And then since pi is a constant, I can pull that pi out front to do the integral from A to B of the radius squared dx. And so if you look up how to do the disk method on a textbook, if you look it up online, you will see that they do this formula. Volume is A to B of r of x squared. So r of x means the radius in terms of x, and then they'll have the pi out front. You are more than welcome to leave the pi in here or move it as a constant in the front of the integral. Both are correct. Both will get you to the right answer. So here's our first example. Let R be the region. Let me make sure. There we go. R is going to be the region enclosed by the function e to the x plus 2. The x-axis, the vertical lines x equals 0 and x equals 2. So we're going to find the volume of the solid generated. So we have to be careful about what we're reading here because it looks a little bit different than your questions before. When that region is revolved about the x-axis. So if you do want to sketch, you can try to draw a mirror image across and then draw some ellipses to get at the vertical lines to get a picture of what this looks like. So I'm thinking this looks similar to a trumpet, like the horn of a trumpet. Now, my drawings on the computer are not that great, but the examples you do in Delta Math, whenever you view an example, you'll have this option to slide the slider to see, and then it will also show you the picture a little better as if you slide that slider. So it's a really nice animation you can play with. Have fun playing with it. But see, it does. It kind of looks like a trumpet or a horn, the end of it. So we're going to find this volume. So we see that the cross sections are circles. I need to know what the radius is. So the radius for each cross section is going to go down, or the cross section of the circle is going to go like this, which means the radius is the length from the top curve to the x-axis. So to get the radius, I'm going to take the equation for the top curve, and I'll subtract the equation for the bottom. So that's still that top minus bottom that we've done before. So the top is e to the x plus 2, and the bottom is y equals 0. So my radius is just e to the x plus 2. So when I go to find my volume, I'm going to take pi. I'm going to take pi times the definite integral. My picture got thrown off just a little bit here. Definite integral from 0 to 2 of the radius squared dx. And my radius is 0 to 2. My radius is e to the x minus 2, or e to the x plus 2, squared dx. I'm going to grab my calculator to calculate this integral for me. So again, you can type in integral. I need to do pi. You can also type in pi. It's pretty awesome. From 0 to 2 of e to the x plus 2. We're going to square that x. So my volume is approximately 189.611, and I think I have to round this to the nearest thousandth. So 0.612. So volume is approximately, and I've already forgotten the number, 189.612. Cubic units. All right, this next one's pretty similar, but it's also a little bit different. Region R is the region enclosed by f of x equals x to the 1/3, the horizontal line y equals 2, and the y-axis. Find the volume of the solid generated when R is revolved around, not around the x-axis, it's going to be revolved around the line y equals 2. So watch out for these words right here. And then here's a picture of how it's going to be revolved. Kind of looks like a traffic cone or even a witch's hat. But the radius looks like it would go from here to here, but I don't have any equations up here, so I'm going to use my radius to be, I'm going to say the radius is going to go from here to there. Now I need to go to the other side because I can't see the equations. So right there, that's the radius. So the radius is going to be top minus bottom. Radius is going to be the top curve. This time the top curve is the straight line 2 minus x to the 1/3. Looks like I'm going to integrate from 0 to 8. So volume is going to be pi times the definite integral from 0 to 8 of the radius squared. And I would type this in. I'll get my decimal. And that's how you do the disk method. So go have some practice and enjoy.